Good afternoon. We are doing our last objective of Unit 1 today. So that means tomorrow we'll be doing the practice test. Monday is going to be the real test. This is a short unit. There were only 6 objectives. Some units are longer, some units are shorter. So we're starting off our year with a shorter unit, 6 objectives. We're at CO6. I can find the least common multiple of a set of numbers. So we talked about greatest common factors, the GCF. Now we're talking about the least common multiple, the LCM. Trust me when I tell you, I've taught greatest common factor and least common multiple for years, and kids always confuse the two. So we're really going to want to pay attention to what that greatest common factor is and how the least common multiple is different. One thing I want to point out before we move on to our lesson came up in my other class. Somebody asked about our textbook and why we have a textbook if we're not using it in class because we have binders in class. That textbook, remember, is a resource. So if you're not sure about how I explain something, math can be explained in many different ways and all get the same answer. There are different ways to do it. My way of explaining it, you go, I'm still not quite getting it. Or maybe you go home and mom and dad are trying to remember how to do this algebra stuff that we're learning and they might forget because that happens. You can say, oh, let's look it up in the book so you can understand what we're doing. So here's how we read what objective page we're on and how to find it in the book. You can see it says text. That means for the textbook. Our first number is the chapter. So this objective is coming from chapter 4. The second number after the decimal, 0.4, that means it's lesson 4. So if you go to chapter 4, lesson 4, it's going to be about the least common multiple. So it might be explained the same way that I'm explaining it, might be explained a little bit different. So if you're having a hard time with how I explained it, you might want to look it up in the book. So now we know our binder sheets, our objectives don't go in the same order as the book. Sometimes they're one right after another, lessons right after another. Sometimes we might go from chapter 10 to chapter 4 to back to chapter 10. Okay, so it doesn't follow necessarily the same way as the book, but we're getting all the information that we need from the book. But this is how we can use that book as our resource. The first number is your chapter. The second number is the lesson number in that chapter. All right, so least common multiple. What is a multiple? A multiple is a number so the number, a given number, can go into. So it's found by skip counting. Which is multiplying. When you skip count, you're multiplying. So if our given number is 3, our multiple is a number that it can go into. So what would be a number that 3 can go into, Emily? 96?
I said 9 or 6.
9 or 6 or 96. They are all multiples of 3. Okay, so a multiple is a number that your given number can go into. So is there only one multiple for numbers? No, because numbers go on infinitely. So your multiples can go on infinitely. My example of a 3, we're skipping by 3s. So any multiple of 3, you skip count by 3. 6, 9, 12, 18, 21, 24, 27, 30. Those are all multiples of 3. Okay, so your multiple is when your given number can go into it, so you're multiplying that number. Remember how factors and multiples differ can be tricky. Here's a comparison. What are the factors of 12? Factors, remember, factor buddies.
Yeah.
What are my factor buddies of 12? Tegan, 3 and 4. Aiden,
Oh, 1 and 12.
1 and 12. Hugo,
6 and 2.
6 and 2. Those are all factors of 12. Now we're going to look at multiples. What are multiples of 12? And let's go in order with this one. So let's skip by 12 in order. So what would be my first multiple of 12, Mario?
12.
1 is our first number we're going to multiply by. So what's our first multiple of 12? 12. Because we're going to multiply by that 1 first. Then the 24. Then what, Gus?
36.
Then what, Evelyn? Then what, Hugo?
60.
Then what, Emily?
72.
Then what, Alexis?
84.
And we can go on and on and on infinitely, skipping by 12s. So that dot, dot, dot means it keeps going and going and going. The important thing to remember with multiples is we always start with 1 to multiply by. What is it times 1? What is it times 2? What is it times 3? What is it times 4? So our factors, can that go on and on and on? No, it's only what numbers we can divide down into. What are its factors? What numbers can divide into it? Multiples are multiplied by 1, multiplied by 2, multiplied by 3, multiplied by 4, multiplied by 5, and it can go on forever. Okay, so key word to think of, greatest common factor, factor buddies. We know our factor buddies. Okay, so if it's a factor, it has a buddy. Factor buddies, we know it is not infinite. It is just the numbers that can divide that you can divide by it. Multiples, you're multiplying by 1, by 2, by 3, by 4. All right, so method 1 for finding the least common multiple. So we have all these multiples. When we're going to look for the least common multiple, we're going to take 2 or more numbers, and we're finding what common multiple they share, the smallest one. Okay. For factors, we were looking for the greatest common factor that 2 numbers shared. For multiples, we want that smallest, the least common multiple.
So you're going to have
Because greatest common multiple, we go on for infinite number. That would be huge. We don't want the greatest common multiple. That's going to be, we can't even say because it keeps going on and on and on.
never ends.
So we want the least common multiple, that both of those numbers, or the 3 numbers, or the 4 numbers, the smallest multiple that they all share. So, to find that least common multiple, the LCM, least common multiple, we're going to use the MCL method. We're going to find out what MCL stands for. Emily,
Why is it factor? Because GCF.
we're going to find out.
GCF.
So, the M, the first thing we're going to do is our M. We want to find the multiples of the number. Now, we're not going to write out the multiples infinitely. Okay, what I always say is write out the first 10 multiples. Okay. Sometimes we can match up that least common multiple in the first 10 multiples. Sometimes we have to go farther, but a lot of times we'll find it in that first 10 multiples. So my 2 numbers are 6 and 10. So I'm going to write out my multiples of 6, starting with multiplying by 1. 6 times 1 is 6. Then just say it out loud for me.
12, 18, 24, 30,
40. 42, no, not 40,
42.
42, 48, 54, 60. That's 10. I said just write out the first 10. Okay. Now I'm going to write out my multiples of 10. I'm going to keep going until, well, let's get in the habit of writing out 10 multiples, and then we're going to see what they have in common. So 10 times 1 is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Now, I could have stopped at 60 because, oh, I stopped at 60 there. Look at that.
30. Or 30.
What?
Or 30.
Oh. So, what we're going to do, we found our multiple. Now let's find the common multiples. So, common multiples. We all are showing up at 30. We also have a 60. So those are the ones that we have in common. So I know that they had 30, they had 60 in common. Now we need to find the least common multiple. So the least is our smallest one. So least common multiple, we worked it backwards, multiple common least, because we can't just look at it and automatically know what the least one is. We have to start with their multiples, compare them to find what they have in common, and then find the smallest one. Now this is a good method to use when that multiple is going to be right in the beginning. Okay, sometimes we get numbers that are like really big numbers, like 154, and then what are its multiples? Ooh, sometimes it gets tricky. So there are other ways to find that least common multiple. So when we have bigger numbers that are trickier with those multiples to find, might want to use the prime factorization, factor trees. So let's see how that works. Are we feeling good about the MCL?
Yep.
Multiple common least, to work our way backwards to find that least one? All right, I'm going to scroll up. Now we're going to find the least common multiple using prime factorization. So, what?
It says table method, which is
Oh, he said that the only thing he changed was the adding in those review ones. Okay, so I have it set up to show us prime factorization, which is a valid method. So we're going to learn that because that's what I have prepared for us today. I didn't know he changed this page on me. So we're going to use the prime factorization. I'm going to show you how that works. So we have 6 and we have 10. There are two numbers. Remember how to do that factor tree. What can we break the 6 down into? 2 and 3. What can I break my 10 down into? 2 and 5. So here's how we use those to find our common multiple, our least common multiple. First thing we do, like before, is we find what factors they have in common. They share a 2. So I'm going to write a 2, just 1, 2, because they share it. They do not share a 3, so I'm going to write a 3. They do not share a 5, so I'm going to write a 5. So if it is a factor that they share, you only write it one time. They share a 2, so I wrote my 2
Oh,
one time.
you will use every single number.
So we shared the 2, so I write it once. They don't share a 3, so I write it. They don't share a 5, so I write it. So we're writing down all the factors that we're multiplying out. If it's a factor they shared, we write it one time because they're sharing it. Now I'm going to multiply them. 2 times 3 is 6. 6 times 5 is 30. I like this method too.
I like this one too.
What? So this is a valid way. Using that prime factorization. Okay. The key to remember though is you are not writing down every single factor because they might share some. And then you're going to get a multiple, but it's not going to be the least common multiple. In order to get the least common multiple, you're going to write the factors that they share one time. So what if they shared like 2 factors? Let me show you. Let's see. Let's say we have let's say it's 30 and 60. Okay, so let's look at what factors they share. So 30 could be 2 and 15. 15 is the 3 and the 5, right? 60 could be 2 and 30. 30 is 2 and 15. And 3 and 5, right? So 60 is 2 and 30. 30 is 2 and 15. 15 is 3 and 5, bringing down the ones that are already prime. Now let's look at what we share. So I'm going to circle a 2, circle a 2. So I'm going to write that 2 one time. Ooh, they share a 3. I'm going to circle a 3, circle a 3. I'm going to write that one time. They share a 5. I'm going to write that one time. Okay, now since I did all of the ones that they share, I'm going to go back and I'm going to write the ones that they do not share. They don't share a 2. So I'm going to write it there.
60.
Okay, so now I'm going to find what the least common multiple of 30 and 60. I'm going to multiply them together. 2 times 3 is 6. 6 times 5 is 30. 30 times 2 is 60. So their least common multiple is 60. I used an easy one because I wanted to show you when we share multiple factors and don't share factors, how we do that. So every time you circle the factors they share, you write it one time. Circle the factor it shares, write it one time. Circle the factor they share, write it one time. Then go back and look to see what is not circled. Every time there's a not circled, you write it. Then you multiply them together. Alexis.
Let's say there was like those numbers, but then there was an extra 2 on both of them.
Then they would share it.
2 again.
Yeah. So if we had another 2 that they both shared, we would circle it and write it. Okay. Every time you find a factor that they share, you circle it and write it. You can only circle a number one time. So if you've already circled the 2 here to share with this 2, you can't circle it a second time to share with this 2. You can only circle the factors one time each. Evan.
So you want to basically just write down all the numbers that are circled and then go back
And write any numbers that aren't circled. But when you're circling it, I circled a 2, I circled a 2, but I only write it one time. Okay. Sometimes I have friends that accidentally write the numbers multiple times. You circle it, you write it once. You circle the 2 numbers, you write it once. Tatum?
How would it be like 60?
Well, look at 30 and 60. Is there a multiple of 60 that's smaller than 60? Our first multiple of 60 is 60, right? 60 times 1. So we can't have a multiple that's smaller than it. So if we were to do it the same thing in the other method, and we had 30 and 60, our multiples of 30, 30 times 1, 30 times 2, 30 times 3, 30 times 4. Let's do our multiples of 60. 60 times 1, 60 times 2, 60 times 3, 60 times 4. And then we circle our common multiples. Oh, that is not a common multiple. Circle our common multiples. 60, 120. What's the smallest one? It would be 60. Does that make a little more sense? Any other questions about the prime factorization? All right. So for our work, find the least common multiple of each set of numbers using both methods. Okay, so you're going to do both methods for these two. Then on the next page, you can use which one you want. So let's do this one first, 15 and 21. We're going to do it together. Okay, so everybody should be looking at 15 and 21. So we can do it together. First way is I'm going to list their multiples because we're going to do the MCL, multiples common least. Say it out loud. What are my multiples? We're just going to go, I think we can do it in 5. Maybe. No. All right, let's just start listing our multiples of 15. 15, 30,
45, 60, 75,
90, 105, and we're going to stop at 120. Now let's list multiples of 21. What's my first one going to be? 21, 42, 63, 84, 105,
136. No, 40. 126.
All right, now let's circle common multiples that they share. No. Look at that. We share the 105, and it's our smallest common, so I didn't go up any higher. That is our smallest common multiple. So we got 105. Now let's do it with prime factorization. So I'm going to put my two numbers on top to make my factor tree. What can I break 15 into? 3 and 5. What can I break 21 into?
7.
What's my next step? Aiden?
You find the ones that they both have.
So which common ones do I have?
After
They both share 3, so I'm going to circle my 3's, and I'm going to write it one time. Do they share any other numbers in common?
no.
No. So I'm done with my share. So now I go back and I write all of my leftover factors that I didn't circle. And I multiply them together. 3 times 5 is 15. 15 times 7 is, shocker, 105. Ooh, I did it right. When I work it out both ways, that's my way of checking my work. I got the same answer both ways. It'll be the same. Now, our next one, we have 3 numbers. How do I do this with 3 numbers? Oh my goodness. I make my list the same way. Multiples of 9. What are my multiples of 9?
9,
9, 18,
27,
27,
36,
36,
45,
45,
54,
54,
63,
63,
72,
72,
81,
81,
100.
90.
Oh, 90.
So, here's the thing. Pencils down. If you couldn't list off your multiples of 9 that fast like Gus was doing, you're going to want to just brush up on your multiplication facts. Okay, I'm not assigning it. I'm not going to say you have to for a grade. Make sure you know your multiplication facts off the top of your head. But you should be able to say 9, 18, 27, 36, 45, 54, 63, 72, 81. You should be able to list them off quickly. This will help you. Why? Why do we want you to know your multiplication facts like that, James?
Because we need them in real life.
You do use multiplication facts in real life, but why is it important in math class? Why is your math teacher, pencils down? Why is your math teacher saying, hey, know your math facts? Priya? Why is it really important in math, Christopher?
So you don't focus on knowing your math class, you just focus on like questions.
Yes. So you're not wasting all of your time on your math facts and you can focus on the challenging math. Some of us are saying, I got this, I know my multiples, I know my factors. I guarantee you as the year goes on, it's going to get more challenging. Okay? Beginning of the year, we're not trying to overwhelm us with new stuff. We can say, oh, I need to remember this from last year. That's right. It's kind of starting to come back. We're going to get into math that's brand new math. You're going to go, whoa, I've never done this math before. Ooh, this was on that math test. This is a challenging math question. Now I know it for when we get to the winter math test. It's gonna be challenging. We don't want to spend all of our time trying to mess around with our math facts. Pencils are down, Christopher. Yeah, everybody else that just dropped their pencil. Yeah. It wasn't just him.
No.
Okay. Important that we know our math facts so we don't waste our time and we don't make simple mistakes. Oh, you know the methods, you know the formulas that we're going to be learning, and you get the answer wrong because you said 4 times 5 was 54. Oops. You messed up your 45 and your 55. It happens. Okay? But you want to be comfortable with those math facts. All right. Let's do our multiples of 15 real quick. 15. 30, 45,
60, 75, 90.
All right, we're going to stop there. Multiples of 18. 18s are harder. They're a little bit harder. So, 18, 36.
54, 72, 90. Easy.
See, because we had our 9s listed out, it was easier to do the 18s because we already had the 9s listed.
Oh,
and we knew it was every other. That's how Gus was doing it that fast. He knew it was every other of our multiples of 9. Smarty pants Gus finding shortcuts for us. So, now, I listed out multiples. What do I need to do? Priya?
Find like the common.
Circle the common ones. Okay, well this one and this one have 18, but 15 doesn't have it, so I can't circle them. It has to be common with all 3 numbers. 36, nope. 54, nope. 72, nope. 90, 90, 90. It is a common, and it is the first common that we run into, so we know it is our least common multiple. Now we're going to do it as the prime factorization. I'm writing it really big so we can see it easily, so I'm taking up lots of space. When you're doing it on your paper, if you need more space, where can you get more space? The page before you, that back side, that's nice and blank. So if you need to move over before, you can write it on there. If you need to go to the back side of the page you're working on, you can go there. but you do have to show your work. All right, so we have 9, 15, and 18. Factors of 9. 3 and 3. Is that my primes? Yeah. Factors of 15.
5 and 3.
Are those primes?
Yep.
They are. Factors of 18.
6 and 3.
Are those primes?
No.
I can break my 6 down. So my 3 I'm gonna carry down, and 2 and 3. Now do I have all primes? Okay. So now I'm gonna do the same thing, but remember it has to be common factor for all 3 numbers. So I see a 3, 3, and a 3 that they all share. Is there another number that all 3 share? No. So I'm going to write down all my leftovers. And I like to draw a line under it as I write it. So I make sure I'm not writing a number twice. I make sure I don't skip a number. So I can see they're all either circled or a line drawn under it. So I wrote down all of the factors I need. Now I'm going to do my math. 3 times 3 is 9. 9 times 5, 45. 45 times 2.
See, that's what happens.
Yeah.
You put too many fruits. No, you don't put too many fruits. It's exactly enough. Yeah, that's enough. Why?
Oh, I should have double checked what I was explaining to you. Okay, let's do this again. Okay, we're gonna say, okay, Miss Gambino, we're gonna erase what we were just thinking. We're gonna block it out of our minds, and I'm going back over to redo. So we had 3, 3, 3, 5, 3, 2, 3. Okay. We share a 3, share a 3, share a 3. Ooh, I see that these two share a 3. I'm gonna put that.
Oh, you can, it doesn't have to.
It doesn't have to be all 3 of them.
Okay.
Look at how sweet that works out. Oh, we erased and went back. Redo. Now there's no other 5 and no other 2. Okay. So if we can match it up with each number, great, we write it one time. If we can match it up with only one other number, we write it one time. If we cannot match it up at all, we write it one time. So let's look at that again. We had a 3, 3, and 3, so we wrote it one time. Then we could still match this 3 up with another 3, so we wrote it one time. We do not have a 5 to match up with that 5, so we write it one time. We do not have a 2 to match up with this 2, so we write it one time. So if you can match it, you write it that one time. And then you go to the next one. Can I match this one? Remember that circling. It'll help you know if you've already matched your number up.
Yes.
If you don't circle it, you will get confused if you've used it already or not. It is important to circle the numbers as you use them so you don't accidentally match it up twice. Okay? 3 times 3 is 9. 9 times 5 is 45. 45 times 2 is
90.
Make sense?
Yeah.
For this, to multiply them all together, yes. You can use your calculator to multiply 3 times 3 times 5 times 2, sure. It doesn't say no calculator. Is your calculator going to tell you what the least common multiple is?
No.
You have to be able to do the math, do the method, and then the multiplying you can use your calculator for. I have no problem with that because you have to understand what least common multiple is in the beginning, in the first place. Calculator won't tell you that.
No. Well, depends on how advanced the calculator is.
I honestly don't think even a graphing calculator is not going to tell you the least common multiple.
Everyone having a different calculator, so.
Right. Yeah, we definitely don't need a graphing calculator in 6th grade.
No, we don't.
Does Does anybody want me to do 3 number multiples again, or are we good? Okay. Voices are calm and quiet, and they're still recording. I want to erase. Okay, so let's look at our directions. Find the least common multiple of each set of numbers. Show your work. You can use either way. Do you want to use the MCL where you list the multiples and circle the common? Do you want to use the prime factorization where you break it down to their primes and match up your commons and then multiply it? James.
What would you do for 3 for a prime? Would you just do like 3 times 1? Or maybe that means you have to go.
So do we have to write a 1?
No.
If we're multiplying by 1, it's going to be 1. So if 3 is already a prime, you would just put 3. And then you would put 8. Okay? So if it's already a prime number, you just have to write that prime down there. You can't break it into anything else. Good question. Any other questions? All right. Second page. There are 2 pages. Word problems. Pat, Mark, and Chris take off from the starting line on a racetrack at the same time. Pat can run a lap in 2 minutes, Mark can run a lap in 5 minutes, Chris can run a lap in 7 minutes. How long will it be until they are all together at the starting line of the track once again? What are we looking for? The least common multiple. So we are doing the exact same math. They just have a whole lot of words in there. But if you read it, you can see when are they all back at the, going all the way around? When are they all going to meet up again? That's their least common multiple. So you can do the MCL, you can do the prime factorization, find that least common multiple. It's the same math that we've been doing. So this is the key thing to remember though, is to read the entire direction. Pencils down real quick. Read the entire problem. Eyes up here. If we put our pencils down, we're putting our eyes up on the teacher. Because this is important. Read the entire problem instead of saying, oh, I know, it's just least common multiple, least common multiple, least common multiple. Because we might get something like, at what time will both stoplights again turn green together? So I'm looking for a time. So here it's in seconds, and here it's in seconds. I don't want your answer to be in seconds. You have to do an extra step. You have to see how many seconds have gone by. So how many minutes would it be? If we're starting at 1:05, what time are we at now? Oh, thank you to my friends that kept their pencils down. Eyes on me, pencils down.
Yeah, we'll have to add it to our.
So you have to find out how long it is and then add it to 1:05. Is very important when we're doing word problems, that we look at what the question is asking. Did I answer the question? Yes, we need to find the least common multiple of 20 and 36, but that's not your answer. Always look to see how can I use that information to answer the question. Sometimes you have to take it a step farther, so be careful. Any questions on the word? Oh my goodness, pencils down. Wow, are we really excited to do our math? I love that we're so excited to do math.
We're excited to get it done and not have homework.
Well, think about all the time we're wasting every time we pick up a pencil and I say pencils down, pencils down, pencils down. You're wasting your own work time. So you think that you're working ahead, but you're really wasting everybody's time. Alexis. Okay. Any questions? All right. So for my friends at home, we hope that you are well and we hope to see you soon. Have a wonderful